section 3 and 4, and I'm just going to point out the things that we've already talked about. Monomial, that's one term. Binomial, 2 terms. Trinomial, 3 terms. And then roots, we've talked about that. Roots, what are the other 2 names for roots? What else do we call a root? No? What was it? X-intercepts, roots, and solutions, not so much for the functions. But think about x-intercepts, roots. I had one other term I used. Begins with Z, ends in euro. Zeros. See how good you're getting at this game? All right. So the roots are the same as your x-intercepts. What's this called? Difference of 2 squares. What's this? Perfect square trinomial. What's this? Also perfect square trinomials. Okay, so here's examples of those. If you are one of the more than 50% of the students in this room who don't know how to factor or recognize a perfect square trinomial, you need to come in and get help. Print the factor review and come in. I will be glad to get you up to speed. This is one of those deal breakers for your success in this class. I don't know what a PST is. So if you don't, and you've been ignoring it because we've only done it a few times, and you think, oh, it'll be okay not to know that, I'm just telling you it won't be. Right? Finding the vertex. What form are you in? Standard form. How do we find the vertex? Excellent. Negative b over 2a. So I would expect that everyone in here can do the opposite of negative 8 over 2 times 1 and get the vertex, making your list from standard form, parent graph, translation vector, or the vertex. What's the vertical stretch? 1. So the opposite of negative 8 over 2 times 1 is going to give you 4. And when you plug in a 4, you're going to get negative 4. So from your vertex, I don't know why these points are on here. Here's 4, negative 4. How do I get to my next points? Right 1, up 1. Right 2, up 4. Left 1, up 1, and left 2, up 4. And on a graph like this, it also gives you your roots or x-intercepts. Very easy to see on one like that. Okay. What form is the next one in? It's not. I don't call it standard form. It's either transformational form, vertex form, or parabolic form. So again, wanting you to be able to talk the talk, don't just be able to look at it and go, oh, I know how to do it. What do you call it? This is vertex form, parabolic form, transformational form. Parent graph is still x squared. Christian, what's the vertical stretch? Sure. Yeah. So are you committing? No? Are you committing? Yeah. To what? My question was, what's the vertical stretch factor? Really? That's your only answer? You have commitment issues, huh? Do you have a girlfriend? See? Commitment issues. Okay, so yes, the vertical stretch factor is always A. Don't be afraid to commit to it. All right? Translation vector or the vertex for this one. What's it going to be, Matt? Right. Negative. How come it's negative? The opposite point of the x, and what was here? 2. So we got a vertical stretch, we got a translation vector, What else do we need to graph, Ben?
You graph.
Is there anything else I need, or am I?
There you go.
I'm good. Okay. So when I go, negative 15, 2. How do I get to my? How do you get to your first point?
Right.
Right one, up 11. Already we're off the charts here. Left one, up 11. So that's one of those ones where, yeah, we can do it, but it's just tough to do. You know, it's tough to get on our graph paper.
If you take it like that and you factor it and add all the stuff, then it just turns into standard form, right?
That's correct. And we've done that yesterday, right? If we take this, square the binomial, distribute the 11, and then combine like terms, should be in standard form.
Because on the quiz, I accidentally did that, and I still want the same thing.
Absolutely. You know what we call that? Yeah, overachieving. That's what you want to. That's what your mom tells you. You're such an overachiever. Me, I would call that. What's that? If you're going to expand this to standard form, then do the opposite of b over 2a to find the vertex. Plug it in. So you get your y-coordinate vertex, and then you have your vertical stretch factor, and then you graph it, and you get the same thing I got. What do we call this? Pain and suffering. There's no way you want to do that. That's like if you need sand for the sandbox, instead of going to Home Depot and buying a couple bags of sand, you go out back with a hammer and a rock and turn the rock into sand. Yes, you get great sand, but for crying out loud, Home Depot sells it by the bag. That's what we want to do here. What form's this one in? Look at that graph. What does that tell you about this one? You know this one's going to be ugly, right? What's this?
Vertical stretch factor.
Vertical stretch factor of an ungodly negative 44. You can go thank Stedman for this one when we're done here. What are your intercepts?
1, 0.
1, 0.
Or negative 3, 0.
And negative 3, 0. That doesn't feel like it's so bad.
So
Where's your vertex?
negative 1.
-1, comma, is that it? $176 sounds good. And then we said negative?
No,
No, positive. Seriously. So negative 1, positive 176. That's what they did to you. So here are your roots, negative 3, 0, and 1, 0. And way up here at 176, negative 1, 176. And it's right 1, down 44. It's right 2, down 176. Okay, I won't ask you to do anything like that on a quiz or a test. Okay, any questions on these three forms? I'm waiting.
Could you work out like that 176?
Plug in negative 1 for x. Negative 1 minus 1 would be negative 2. Negative 1 plus 3 would be positive 2. Negative 2 times positive 2 would be negative 4. And negative 4 times the lovely and talented negative 44 is that negative 1 or positive 176.
Thank you.
Okay? So remember, we always get the x coordinate by adding these two and dividing by 2. And then to find y, just like standard form or anything else, plug that sucker in and get the x, or get the y. Okay? Add the two x-intercepts up and divide by 2. Remember, your intercepts are always equidistant from your axis of symmetry. So if we add them up and divide by 2, that'll give you the x-coordinate of the vertex and the equation of the axis of symmetry.
So that's what it looks like. We fire a bullet up at an angle.
What do you mean?
The
Like the
gravity.
path? That would be, yep, a bullet would follow that path, but it doesn't have to be fired up. It can be fired straight. It's still parabolic. Every launched object will be parabolic. to factoring. Okay? And we're going to start with basic factoring. What's our first step to factoring? Greatest common factor. Please don't overlook that even when you see other steps ahead. Check to make sure something in common doesn't exist. Bless you. What's in common here?
4 times 2x.
So the 4 is common. What's left?
2x plus 1.
Okay. Now, the idea behind why do we need to know how to do the factoring, one of the applications of this, if we made this into a function, y equals 8x plus 4, then we could rewrite it as 4 times 2x plus 1. And in the linear form, that's just not a big deal. 8x plus 4, if we were going to graph this, we would plot the 4 and use the 8 as the slope. And you'd go up 8, right 1, down 8, left 1. And you'd be able to get that graph pretty quickly. So the linear application is just not as critical for us. Why do we need to factor? What does the factoring do for us? What did it tell us? When we're in this form, what can we get from here that we don't get from here? You get the x-intercept. This right here, if you set it equal to 0, is going to give you the x-intercept when you have it in factored form. There's only a couple of people in the room who can't factor worth a lick when it comes to trinomials, difference of the squares, PSTs. Only a couple of you. If you think you can be invisible with that, you're wrong. Come for help. It's very important that you can do this and that you can do it almost instantaneously. Okay, x squared plus 14x plus 48. If you factor it, how does it factor? X plus 6, x plus 8. So 3 people can factor it, bam! And 33 people sit here going, and of those 33 people, most of you can get there, but there's still a handful who can't. And if you can't, and you're not asking questions, shoot, come for help and we'll do it where you don't feel like you have to be embarrassed if you're embarrassed. And I don't know why you want to be embarrassed. It's a guess and check. If when this is a 1, that makes this have to be x and x. You need factors of 48 that add up to 14. You can go through that list pretty quickly. 1 and 48, 2 and 24, 3 and 4 and 6 and 8. So you can squeeze that out really fast. How do you get really fast at it? Though it's a practice thing, just like everything else. Okay? What good does it do us to be in a factored form? What does it tell us? X-intercepts. Very good. So if we were to factor that, we know the intercepts are going to be at -6 and -8. When we hit the graph, here's -6, here's -8. Imagine that. The vertex has to be halfway between them at -7. How would I find out the y-coordinate of the vertex? Plug in the x. You can plug it in here or into the factored form. When you plug it into the factored form, you get -1. So -7, -1 is your vertex. Vertical stretch factor is still a 1. Why am I going through this? Why are we talking about it? Because when you factor, you get your x-intercepts. The honors kids are doing polynomial functions where powers of 5, 6, 7, 8, so that they're factoring these things out and getting multiple binomial factors. X plus 6 squared times x plus 8 to the 3rd times x minus 5 to the 4th times x plus 1. And they're able to do that graph in about 30 seconds. They can do these graphs. Boom, boom, boom. If you can't factor, you're toast. Doesn't work. So you've got to be able to be totally dialed on the factor. How's the factor? I usually go plus first and minus second. The plus will never be factorable, but the minus sometimes is. That's how it factors. What do we find from that? X-intercepts. Where does the vertex have to be? 0 something. If you plug it in, it's 0, -121. So you know when we hit this on the graph, you're going to see it like this. It's just not going to be pretty. So we're here, here, and then downstairs in the, I guess it's a science room downstairs. Who's in there down there? Who is? Oh,
Sorry.
the actual teacher, Mr. Thomas?
Yeah, Mr. Thomas.
Yeah, not the science guy?
No.
But down there is where the vertex would be. So factoring versus solving. Big issue here. Can you solve this?
No,
Why not?
there's no.
No equals, there's nothing to solve. But can you factor it?
Yeah.
Yeah, absolutely. How's it factor?
X minus 7, x plus 6.
Okay, can we solve this?
Yeah.
Yes. How we solve it is we want to make sure we're set to 0, then you factor. But it's equal to 0. What is ZPP? Zero product property. It's why we learn the zero product property. If you have something times something equals 0, then one of those things has to be a 0. So what is x equals?
7 or negative 6.
Okay? Can't solve. Expression. Can solve an equation. This is just an equation. Can you graph this? Why can't we graph it?
And
There's no y's. It's not a function if you're graphing. You can graph it on the answers on a number line, but that's it. That's all you can do. Remember roots, x-intercepts, zeros. All mean the same thing. It's where the graph crosses the x-axis, and they are always written as an ordered pair, something comma 0. Anyone learn anything new yet? All review, right? Okay, maybe I reminded you something, but you didn't do it. I didn't give you anything new. You haven't done it yet. Determining the roots. Now, instead of a 0 equal, we have y equals, or function notation, f of x, g of x, h of x, equals. If you want to find the roots, we replace the y value with 0, because we know every root has a y value of 0. So if I want to find them, we place it equal to 0, and we factor, and then set each factor equal to 0 to get our roots. 7, 0, negative 6, 0. You can only do that when you start with a function. So if you don't have a function to begin with, you can't do that. You can't be asked to find the roots. Remember, zero product property. If you have something times something equals 0, either A is 0 or B is 0. There's no way that can't be true. There's no way that you can't get one of those to be true. And if you can, you need to share. If you can tell me a value for A or B, A and B, where neither of them is a 0, and that's still true, we need to write a book. Okay? So, again, can I find the roots of this? No. We can find the roots of this by setting y equal to 0, factoring, and solving, which is what we did. Can we solve this? What do you get?
X equals 9 or negative 7.
So the roots for that equation would then be what?
9, 0, negative 7, 0.
Can you have roots for this?
Yes, we can.
Can you have roots for this?
Yes.
Can you have roots for this?
No.
Why not?
No.
There's no y.
It's not a function. You've got to pay attention to those details. So when we're here, can we have roots? No, you can only solve. Here, we can find the roots. We can't find the roots there because it's not a function. So what we did, or what we're doing, is we're looking at it, and the roots, again, are the same as the solutions for this. The x values of the solution of this become the x-intercepts here and here.
Why do you write such big equations
to bother you. X squared minus 2x minus 15 is, this is your function. You can factor it. How does this one factor? Minus 5 because it's a negative in the middle and a plus 3, which gives you x-intercepts where? 5, 0, and negative 3, 0. So your x-intercepts for this equation over here are going to be 5, 0, and negative 3, 0. Okay, that's the x-intercepts for that. So when we graph, you would expect it, negative 3 and 5, that's your intercepts. Halfway between those, when you add those up, you're going to be at negative, or you're going to be at positive 1. And then to figure out what the y value is, you're going to plug in here. 1 minus 2 minus 15 will be negative 16. You can see down here 1's negative 16. Too fast? Is everybody okay? It's a lot of material coming at you guys. What form is this in? Standard form. Okay? This is a function. It's asking you to find the zeros. What do you do to find the zeros? Factor. Okay? To find the zeros, you want to factor y is equal to x plus and x minus 4. So your x-intercepts, or your roots, are going to be at negative 7, 0, and 4, 0. All right? If you add those together, negative 7 and positive 4, you're going to get negative 3 divided by 2. Will give you where the y coordinate is going to be. So the vertex has to be at negative 3 over 2, comma something. So again, look at, there's your 4, there's your negative 7, here's your negative 1.5 way down here. You'll find your vertex. Right now we're just concerned with the x-intercepts, finding the zeros. That's what we want to be able to do. Look at this next question. This one's a little bit different. And this poses a unique situation for us. What does this do for us? How does this factor? Right? This is a PST. And if you don't recognize it, you might miss that it's a PST. And you might miss that your only x-intercept or root is where? Is 2, 0. Because this factor is being squared, this is actually called a double root. Because this factor appears twice as a factor, x minus 2 times x minus 2, we call that a double root. And when we're dealing with the quadratic equation, the double root also means that it's the vertex. And now, if you look at this equation, you say, oh, this is in vertex form, or transformational form, or parabolic form, whichever term you like. But we know that right here, 2, 0, with a vertical stretch factor of 1, that's all we would need to do the graph if we wanted to graph this. Right 1 up 1, right 2 up 4. Left 1 up 1 and left 2 up 4. Going to give you that same deal. It's just your parent graph. Perfect squared trinomials are a big deal for us. Because that means the vertex is the x-intercept, and that x-intercept is a double. And when it's a double, the graph will either come down, kiss the x-axis and go right back up, or if it was a negative, it would come from the bottom, kiss the x-axis as a ceiling, and come back down. Okay, just like throwing a ball off the ceiling, it goes up, the maximum height is the ceiling, comes back down. If you bounce it off the floor, it hits the floor, lowest point, comes back up. What form are we in? PST? No, not this one. So we can factor it, and again, how do you get good at that, right? Some of these people, they're just nails at this stuff. How do you get there? You practice it. You practice and you practice and you practice. Or not. Speed isn't everything. Speed is not everything.
It's little ones like oh no.
But again, what we're specifically looking for in this lesson, the whole reason of this is factoring, which gives us x-intercepts. So when we're doing this, you're going to get negative 6, 0, 1, 0. You get that from factored form. Graphing it, if I just say graph, you do not need to do this at all. And if I was graphing this, I would have used opposite of b over 2a and done it that way. I'm less likely to have factored this, even though factoring will help. So we have negative 6, 0, and 1, 0. And you can see that the opposite of 5 over 2 times 1, negative 5 halves, negative 2 1/2 is where that vertex is going to be. Plugging it in, you know, that's just a pain. We talked about that earlier. And you can see that graph's going to be pretty far down. But right now, just x-intercepts is our motivator. This is Stedman's dog. How many of you had Stedman before? So you know the name of his dog? Judah-Man. Judah-Man is no longer the man. It was the man. Okay? But that's his picture of his old dog. Okay? See the frame on the picture? Based on what we have in this picture, I want you to find the area of the frame. Yeah. Great, tell us. I want the area of the frame is, and it is.
Oh wait, totally. I thought that's just the area outside the
Nope, I want you to find out what the area of this frame is. So I want you to take the time to do. So how do you find the area of the border? How do we do it? How do we do it with the wood? We have a big piece of wood. We cut a hole in it. How do I figure out the area that's left? Not in general, just tell me, I have this big piece of wood, and I cut a hole in it. How do I find out the area that's left after I cut the hole?
Find the area of the whole piece of wood, then subtract the area between those parts.
Okay, so we're going to take the area outside and subtract the area inside, or the hole that we made. And in this case, you were about to tell us was
X squared
minus 4 feet squared, or 2 squared. Okay? Or x squared minus 4 is going to be the area of the border, which we said was 5. And if you want to figure out what x is, you have 2 ways to do it. What could we do? We have an equation. Back to a long time ago now. So what would you do? You have 2 choices. You could add 4, so we're going to get 9 equals x squared. Be careful with your answer next, folks. What's the answer for x? That wasn't being very careful. We got to get plus or minus 3 because you square rooted x squared. Doesn't matter. You're doing math now. So you can't not get this as your answer. Okay? Yeah. I agree with you. I'm not arguing with you, but when you solve for x, you better get plus or minus 3. And then when you give me the answer, the frame is 3 feet by 3 feet. It's your answer.
Because you can't have a negative distance.
Okay? Your answer is here. Your algebra is here. What would my other choice have been at this stage instead of adding 4? Before I factor, though. You could have subtracted 5 and set it equal to 0, and then factor. Right? You would have got x plus 3 minus 3, and that would still give you the negative 3 and positive 3 answers. Good or no? Good? Okay? Okay, so if this assignment is on your calendar, that's the first part that you need to look at. This is from the review of factoring again. These are the 7 steps for factoring that you should know. Factoring out what's in common, difference of 2 perfect squares, looking for a perfect square trinomial, PSTs. Again, I would say that more than 50% of you can't do that right now. If you go online and look at the factoring review, it's really, really an easy thing to do. Factorable trinomials for these 4, 5, and 6, you can do guess and check. You can do some method, borrowing from the clouds, diamond method, box method, whatever you want. But you need a method for factoring trinomials. We talked about sum and difference of the cubes a little bit early on. And then 4 terms factor by grouping. I don't know that we've done a whole lot with these 2. Okay? But you should be very familiar with everything in here. So when you look at 3x squared minus 10x plus 8, and I want you to find the zeros, I need you to be able to do that. And some of you can. In fact, the vast majority of you can. And some of you are in denial of your factoring abilities. And this chapter, you're going to get run over on. You need to be able to factor it, and whatever method you want to use is up to you. It doesn't matter to me which method you use. But you're going to get a 3x and an x, and you're going to get a 4 and a 2, minus and a plus. The method you use doesn't matter to me. That was guess and check, where I did all the guessing and checking in my head. It's not correct.
2 times negative 4 is
Oh,
negative 8.
I had a negative 8 that I was working with. You're absolutely right. So what is it?
3x minus 2x minus 4.
No,
No, wait.
3x minus 4x minus 2.
Yeah, we
Yeah,
need.
sorry. 3x minus 4x minus 2.
Yeah, you got. Nope, that still doesn't fix it.
2 times 3x is negative
Got it. Thank you. I was using minus 8. My bad. So you need to have a method, whatever that is. If you're doing borrowing from the clouds, that's a really low-tech way to do it. 3 times 8 is 24, and it's positive. I need factors of 24 that add up to give you 10. But they add to 14. Forget about the signs. I just need 2 numbers that multiply to 24, 6 and 4, and add up to 10. Since the number in the circle is positive, both of these factors get the sign of b, which in this case is negative. Borrowing from the cloud says both binomials get a 3x. One gets minus 4, the other gets minus 6. What's in common in the first binomial? Nothing. So that's going to stay 3x minus 4. What's in common in the second binomial? 3. If you factor it out, you get x minus 2. This 3 that you factored out will always be the same as the original a, and we throw it away. I don't care how you factor. I only care that you can factor. And if you are struggling with factoring, and I've got a few people trickling in, print the factor review. Come in and let me help you. You cannot keep ignoring this. Finding the zeros. See if you can find the zeros of this one right now. So you can see, if we do borrowing from the clouds, we have a negative 90 in the circle. Factors of 90 that subtract to give you 1 are 9 and 10. Since it's negative, only the big factor gets the sign of b this time. So that makes the 9 negative. 6x minus 9, 6x plus 10. What's common in the first binomial? If you factor it out, 2x minus 3. What's common in the second one? And you'd be left with 3x plus 5. And if you notice, again, the 3 times 2 is 6. And we throw those away. So your x-intercepts are going to be at 3 over 2, 0, and negative 5 over 3, 0. Very unlikely, no matter how good a job you do, rough, that you're going to be able to identify the values of your x-intercepts from the graph. It's not going to happen. But from factoring, we can do that. Right? So all of these, when you're looking for x-intercepts, y becomes 0, and then solve for x. The only thing else I want to show you is these area problems. They're going to be asking you to solve for x. You're going to do that by writing an equation. Then you'll see area of a square. What's the formula for area of a square? Side square. What's the formula for area of a rectangle? How about a triangle? 1/2 base times height. Okay, so you have 2 parts to tonight's homework. Please make sure you get it all done and come in the morning if you're struggling.